Okay, so doing the second one, because the first one doesn't work out. So doing the second one, I would still do oxidation numbers. This ends up being, oh, please, for the love of Pete, work. -2, 2 times 4 is negative, positive 8 divided by 3 is 8 over 3. Oh, that's nice. 8 over 3, lovely jubbly. 0, negative, positive 3 and negative 2, and 0.
Positive 6 and negative 6?
No, because
Okay, well, -2 times and times, but I didn't need to do that because it's just not going to come up. You can. You can do that. So the bridges then go from your lovely MNs and your a little bit easier ALs. So let's conquer the ALs first. ALs change from 0 to 3. I increase in number, so it must be oxidized. Therefore, it lost 3 electrons. Okay with that? Do I need to multiply that by any 2's? You might have because of the other 2. Did you? No? Okay. No. Magnesium, the number is reduced, so it itself must be reduced, therefore it must have gained electrons. And how many did it gain?
8/3.
8/3 of an electron. And at first that feels very awkward, but then that was per species. But in the compound, I have 3 Mn, so this is happening 3 times. And so therefore I have 8 electrons in each compound that are being gained. So now it's time to balance the electrons. So I've got 8 electrons gained and 3 electrons lost. The lowest common multiple is
24.
24, so I'm going to multiply that by 8 to multiply that by 3 to get 24 electrons gained and 24 electrons lost. Everybody okay so far? Now I need to bring my numbers up the bridge. I need to bring a 8 up the bridge for the aluminums. And I need to bring a 3 times 3 and 9 up the bridge for my manganese. So I want 9 manganeses and I want 8 aluminums. Okay, Craig, phone away. The 8 goes up there. The 4 goes over there. Why 4? Good, because there's a little 2 subscripts, so that still makes 8 aluminums. Manganeses, I need 9 of them, so I'm going to put a 3 there. And then 9 over there. And balancing by sight, I just want to check my oxygens. 12 and 12, because that's a messy 4, but it is a 4. And so my oxygens work out too. Okay? You happy with that one?
Yes.
Good. I hope so. All right. Questions? Let's leave it on a high then. Okay, so moving down the paper then. So I'm going to go to the computer. So moving down the paper, the next page asks you, come on. Balancing under acidic conditions. Okay? So don't panic. Don't panic. This front page that we had over here, okay? This front page that we had, this bit was the quiz that you just wrote. Right? So there to there, to there, to there, to there. That's it. That was the quiz that you wrote. This bit was the bit that we just did as an example, where we balanced, like, we just made sure the oxygens worked out at the end there. Okay? Now, sometimes if it's an acidic condition, before we make sure it all balances all right, after we've done our bridges, after we've brought our numbers up to the top, we then have to look at this fact that it's acidic condition. And we go down this way. Okay? We include water and hydrogen. That's what this says. We include water and hydrogen. That was a bit too vague for me, so I've written on your sheet that you're going to balance the charges by adding H+.
You physically write in.
We physically write an H+ because it's acidic condition, so therefore we have H+ as well
To help, just help balance.
to help
overall
balance the
condition.
charges. Okay, like the fact that you'll see when we get to the example. Then the last thing it says there is that you, oh, let's see, this doesn't love me, this board, does it? Then it says you're going to add water to balance out the hydrogens and oxygens. Okay? Do you know what? I'm going to get somebody to actually hold the camera, and just that'd be so much easier. Okay, so this is what I mean. So let's go down. Let's go over to that sheet. Maybe if it likes me today. Okay, go down, 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 down here.
One more down.
Okay, so balancing by oxidation numbers under acidic conditions. So the first thing we do is still the same we did last time. So I still assign oxidation numbers. Okay? So can you see why I told you oxidation numbers were so important? Okay. So the first thing I do is assign oxidation numbers. This is -2, 2 times 2 is -4, +4, and this is +2. Everybody okay with those oxidation numbers? I'm doing them that fast. Okay, so now, by the way, this is a half reaction. So I'm only going to have one bridge, one issue, one problem. A half reaction has the plus E's somewhere in there. So I've changed it slightly for you. Okay, so what's happened? The Mn has changed from a 4+ to a 2+. How did it do that? Gain 2 electrons. So because it's sort of a bit squishy already, what I'm going to do, oh, I don't have an undo button anymore on this. What I'm going to do is instead of writing the bridge, I'm actually going to squeeze in MnO2 plus 2 electrons goes to Mn2+. So showing my gain of 2 electrons. On the bridge you would have written gain 2 electrons, right? That's what it looks like in a half reaction. Those two things should almost be simultaneous in your brain. Everybody okay with that? Okay. So there's nothing to bring up the bridge because I don't have to multiply it by 2. There's no little 2 here in the Mn. I don't have to balance the gain and lost because this is just about the gained. So I'm cutting out all those steps and going straight to the balance the charges. Okay? Now this type of question very much will be on your diploma. There's a high percentage. Many diplomas have this kind of a question. Okay? The correctly balanced half reaction under acidic conditions of MnO2 becoming Mn2+ is the following. A, B, C, D.
So they would have one on acidic conditions and one on neutral conditions.
Maybe. Or perhaps one or the other.
Okay.
Okay? But I've seen a lot of acidic. And a lot of half reactions. Okay, so so now we're down to the stage where we balance the charges by adding H+. So look on the left. What's the overall charge of this side? -2. Can you see that?
Yeah.
Because of the 2 electrons. So I have 2 minuses on the left-hand side. What do I have on the right-hand side? 2 positives. Are those the same? No. So I can add H pluses to this side because it's an acidic condition. So if I listed, remember before you listed your entities? That would be an entity that I listed. so I can have it in my half reaction, just like you would have it in your data booklet. So now what? How many H pluses do I need?
2.
Do I?
4.
I need 4. So this becomes 4 pluses and -2, so that totals +2. That's pretty cool. Good. And this also totals +2. Okay? So I added H plus to balance the charge. So now I have a total of +2 on the left and a total of +2 on the right. And then the very last step is to add water to balance my hydrogens and oxygens. So what side do I need them on? This side. And how many waters? 2, because I've got 4 H's here, so 4 H's there. 2 oxygens, 2 oxygens. And that is a half reaction, balanced half reaction under acidic conditions for MnO2 becoming Mn2 plus. Okay? Happy? The next one isn't a half reaction, but rather it's a full reaction. So we've got a little bit more work to do, but that just helped us see the premise. So okay. So again, we still assign our oxidation numbers. -2, +2, 0. +1, +1, +2, -2. So this must be -1 and +2.
Honestly.
Have I done that right?
Yeah.
+1, +2, +1, that's +3, -3, yeah. Yeah.
Your mass.
So the bridges go where?
SN to SN.
SN to SN and N to N. Okay, I'm doing 2 bridges because it's a whole reaction here. Both 2 things are happening, so it's not a half reaction, it's a net reaction.
Oh.
So I'm now going to do exactly the same thing we did 2 questions ago. All right, the whole balancing thing. So this has gone up in number, so it must have been oxidized, so it must have lost, and then 2 electrons because it's 0 to +2. This has gone down in number, so it must have been reduced, so therefore it has gained. It's gone from 2 to -1, so that's 3 steps, so that's gained 3 electrons. And that's where we ended for our quiz. Everybody okay with that? Now I look for little subscripts, of which there aren't any. Hooray! And then I balance the electrons gained and lost. So what do I need to do?
Times by 3 times by 2.
Right, times this by 2 to get 6 electrons gained, times this by 3 to get 6 electrons lost. So I've got 6 and 6, which is great. Bless you. Okay. So then I bring that 6, then I bring those numbers up. So I'm bringing the 2 up for the nitrogens. I want 2 nitrogens, and I want 3 tins. So to get 2 nitrogens, I would put a 2 there, and a 2 there. And to get 3 tins, I'd put a 3 there, and a 3 there. And before I balance the rest by sight, before I get to that point, I'm now going to balance my charges first. So looking at my charges, neutral, neutral. So the charge on the left-hand side is 0. The charge on the right-hand side is 0, and then 3 +2s. So +6 overall. And 0 overall on that side. That's a problem. So I need to add 6 hydrogen pluses, hydrogen ions, in order to have now not 0, but positive 6 on the left-hand side of the arrow, and positive 6 on the right-hand side of the arrow. Everybody okay with that step? Yeah. Okay. And then what's my step after the hydrogens? Water. So how many waters am I going to need? Well, where am I going to need my waters, first of all? On the right. Normally it's the opposite side of where you put your H pluses, okay? Normally it's the opposite side. Right, so if I have 6 H's over here, and I have 3 6 H's over there, oh, do I need any waters?
You have 5.
2, 3, 3 times 2 is 6. Hydrogens are balanced. Oxygens are 2 if you have no. Oxygens are 2 if you have a look. 2 O's and 2 O's. So I don't need any water. Everybody okay with that? And now, and I've balanced the rest by site, but it's all balanced already. Like there aren't any K's that we haven't looked at or something.
Do the class change.
Happy dappy? Not really?
Happy down.
No. Get
Except
into it.
once we put the subscripts, then I feel like that's gonna just make it.
That make it, well, and chances are you're not going to get a subscript one at all. Okay? So, just a minute, could you write down the nitrogen monoxide half reaction if they asked you write the reduction half reaction for this, and it's exactly as I've got it typed or written on the sheet, like the sheet that you've got in your hand, you know, my handwriting on that one. Write the reduction half reaction for the following in acidic conditions. Okay? You would still do all this, and then you would just take out the reduction bit. So I'd write down, I've got 2 NOs. See that? They have gained 3 electrons, so plus 3 electrons, went to NH2OH, 2 of them. It's actually gained 6 electrons. And I needed 6 hydrogens to help that out.
And if there was waters, you put the waters in.
Yeah. Okay? So sometimes they ask for the entire question to be balanced. Sometimes I will ask for the half reaction. But, you know, this is, you should be able to kind of, it's all the same thing. You've got to do the same steps to get it. It's just how you communicate your answer, what part of it you communicate. Okay. So, let's do C together. Okay, CD, V2, and VO3 minus. So this is a 2 plus charge, this is a 2 plus charge, this is a 0 charge, this is negative 2, 2 times 3 is negative 6, positive 5. Can you do that fast?
Yeah.
Probably do it faster without me talking, actually, because I'm probably further more. Okay. So the cadmiums went from positive 2 to 0, and the V's went from positive 2 to positive 5. So because the CD's charge went down, it must have been reduced, and therefore it gained 2 electrons. And the V's must have been oxidized because their number went up, and it must have lost 3 electrons. And that was the quiz, so we're all feeling good with that, hopefully. Or at least 80% good, so that's about what we got on our quizzes. And now you look for little numbers, of which there aren't any. Hooray! Okay. And it's under acidic conditions, so we've got that in the back of our head, because that was at the top of the sheet. And now I start looking at the number of electrons gained and lost and balancing those. So 2 and 3, right? So I want to multiply this by 3 to get 6 electrons gained in total. Multiply this by 2 to get 6 electrons gained in total. Or lost in total. And then I bring my multiplication up the bracket. So there's 3 cadeniums, so 3 and 3, and 2 V's, so 2 and 2. And a student might be thinking, woohoo, done, right? Because it looks done. But and a Chem 20 student would think they were done, but Chem 30 students know that not only do species have to be balanced left and right, but charges do as well. So here's a very good example of science 10 would not, they would think they were done. I got 2 B's, I got 3 CDs, I'm good. Okay? But now in Chem 20 we're like, oh, your charges have to be balanced as well. So I'm looking over here and I've got, I'll pick a different color, maybe. I've got 3 times 2, so I've got 6 positives in total, and 4 positives on this, so I've got 10 positives on the left-hand side. Everybody see that? Some students find that really difficult to see. If you're one of them, tell me and I can come to your sheet and point for you, okay? This is a 0 charge, this has 2 negatives, so therefore it's -2 in total. So what do I need to do to balance it out? Add 12 H pluses to this side.
6 waters to the other side.
And then I've got to balance my oxygens and hydrogens by adding water, so I'm going to add 6 waters on that side to balance those out. Feeling okay? Raj, feeling okay?
Yeah.
Okay. I also wanted to talk to you about disproportionation. I forget actually if I was supposed to balance this under acidic conditions or not. But anyway, I think so. I think I do. Ultimately, what I really wanted you to understand about this example is the term disproportionation. Disproportionation means one species is both oxidized and reduced. Because remember, I have a whole flask of NO2s. I don't just have one. So some of those will become NO2 minuses, and some of them will become NO3s. Okay, so let's just do the oxidation numbers so that becomes a bit more obvious. -2, -4, +4. -2, -4, +3. -2, -6, +6. So at first, this nitrogen is going from 4 to 3, therefore it's reduced by gaining 1 electron. And it's going from 4 to 6, which means it has lost 2 electrons. Okay? So I might ask you, identify which of these reactions is a disproportionation reaction. Hello. Yes, you may. Sorry about that. It's okay. I thought you were just gabbing out there with the... Okay, don't worry. You could have knocked. Feel free to interrupt. Okay, blah, blah, blah.
Yeah.
Okay, so I might ask you a question that can you identify the disproportionation or define disproportionation or... Okay? Yeah. Now, let's balance this because you should be able to balance this as well using our other skills. Lindsay, did you have a question?
How would you define it?
It is a species that has both lost and gained electrons in the same reaction. Okay, so once I've done this, I then look for my little subscripts, of which there are none, yay! And do you know what, for the harder questions, there probably won't be. That's why I've done none for the last 3 questions. So, no subscripts, hurrah. Then, the next thing I do is balance the lost and gained. So what do I need to do about that? Somebody who's not very confident at this yet. Leaf, what do I need to do next? Good. So now there's 2 electrons gained and 2 electrons lost. Then what do? Jillian?
Take the numbers out.
bring the numbers up. Tell me how to do that. Okay, so this is where it gets a bit confusing because this bridge normally said I needed 2 n's, right? And this bridge is telling me I need 1 n. So now I have a problem. Okay, so some students find it helpful to write an extra NO2 and treat it as 2 bridges and then combine them in the end. And some people are able to do that in their head and just hold that place in their head. But at any rate, if I pretend that this bridge goes to this newly formed, not newly formed, but like I'm just going to write it down twice. I want 1 of those and I want 2 of those. So in total, how many NO2s do I have on the left? 3. So another student might not have written that. They might have just put a 3 there and not written that
So
at
you
all.
could just add the 2 different multipliers?
Yeah, it's 2 plus 1 for that spot. Okay? So I've got 3 NO2s on the left. And I'm going to balance the rest by side. I'm just going to rub that out and I'm going to put a proper 3 there. And on the right, I'm just going to balance the rest by sight in terms of my nitrogens. I've got 3 nitrogens and I've got 2 nitrogens. Which one do you think I should double? The one on the left because it's this bridge.
Wait, I thought you already have 3 on the right.
How do I?
Oh wait, sorry, never mind. You just carried the 2 out.
Yeah. Everybody okay? If you're not really okay with that, draw another NO2, do the 2 bridges, and you will get the right answer. You will have put the 2 there because it's part of that one, and you'll put a 1 there, and a 1 there, and a 1 there, and just exactly like it was before. And then at the end, you just add those 2 things together. Okay, then, before we balance by sight, what are we supposed to do? Charges. So on the left, I so far have neutral. And on the right, I have -2, because I've got 2 negative ones. -2. So I need to add some H pluses. Oh, pardon me. Pardon me. No redo button. I have to add some H pluses to this side. 2 of them. So that side's neutral and that side's neutral. And then I'm going to have to add water. 1 water to that side. And my oxygen should be okay now. 2 times 3 is 6, plus 1 is 4. And 7, thank you, whatever that was. And this is, oh, that's where, 4, and 3 is 7. So you can still balance it, you know, but now you also know the definition of decoordination, and you know how to handle them by keeping them as like 2 different compounds and then combining them into 3. Yes, Lindsay.
Is there this proportionation
Yeah. Yeah, it's just that the charges would have been balanced at the end of that. You would have looked, charges are all fine, I don't need to add each plus. Okay? Okay, so lastly, because we're just still on this booklet, then we can finish the booklet. These ones are for us to practice. Okay? We should be able to succeed on all of those. And then on the last sheet of this booklet is everything we've done in chapter 12. So in chapter 12, we balanced reactions by half reactions. Do you remember that? Right? Write them beside each other, multiply it by however many so the electrons cancel out. We probably looked them up in our data booklet if they weren't given to us. Then we looked at whether reactions were spontaneous or not. The waterfall flows down or up. Then we balanced reactions by oxidation numbers, which is what we've just been doing right now. Then we balanced them under acidic conditions, also what we were doing right now. We also looked at rusting and prevention and titrations. That's it. That is chapter 12. Because I know there's been a lot of coming and going, so I thought a nice list would be a good idea. And your test on Friday will be on those things. So what are we doing tomorrow? Preparing for our chapter 12 test. It'll be the work class. It's only half a class because it's a checkpoint, right? Yes.
I will be here Thursday or Friday.
Thursday or Friday? Oh dear. Okay, let's talk about that.